Hello, ladies and gentlemen. Chapter 5.1, using property of exponents. All right, so property number 1 is the product of powers. Okay, product of powers property. So we have a, remember a is called a base, to the m power, and a to the n power. So the bases are the same, and so therefore we add the exponents. Okay, product of powers, we add the exponents. So in our example, again, we have a base of 7. So we just add the 4 and the 5 together. So 7 to the 4 plus 5, which is 7 to the 9th power. Okay, pretty simple. Let's move on. Number 2, it's called power of a power. So you will notice in this problem that we have a base with an exponent with another exponent. Okay, so we have an exponent to an exponent. So a power of a power. So when we have a power of a power, we multiply the exponents. Okay, so in this example, we have 6 to the 3rd to the 5th power. That simply means 6 to the 3rd times 5, which is 6 to the 15th power. Anytime you want to verify any of these problems, you certainly can use the calculator. Okay, for example, if I type in 6 to the 15th power, that's going to be a very large number. Okay, this is actually scientific notation, which we'll talk about in a little bit. But if I also take and type the original in, okay, 3 to the 5th power. So, sorry, I said that wrong. 6th to the 3rd power to the 5th power. So I would do this, parentheses 6 to the 3rd power. And then I would do it to the 5th power, and you'll notice it's the exact same thing. Okay. All right, moving on. Power of a product. Okay, here you notice that we have 2 bases. Okay, it can be more than 2 bases. Okay, it could be 3 bases. And the key here is, ladies and gentlemen, there is a times between the 2 bases. Again, it could be 3 bases, but it has to be a times symbol between the bases. If it's a plus sign or a minus sign, that goes back to FOIL, first outside, inside, last. Again, this is a times sign in between. So what does that mean? That simply means that this exponent will go to both of those. Again, it has to be a times sign in between it. So like this one, 3 times 5 to the 4th, okay, that's the same as 3 to the 4th power times 5 to the 4th power. Now you cannot multiply it. Once you get it 3 to the 4th power times 5 to the 4th power, you can no longer multiply the bases. You could have done this, okay, but that would defeat the point of this property and showing you an example of it. You could have multiplied the 3 and the 5 together first, and then that would be 15 to the 4th power. But that's not what I wanted to show you with this property. Okay, same thing with this next one. Okay, notice this one, however, we have x squared times y cubed. Okay, well, we're going to multiply the 5 to both of those exponents. So this becomes x to the 10th times y to the 15th. Okay, so again, property number 3 is a power of a product. Moving on. Okay, negative exponents. We never want to leave an answer with a negative exponents. Okay, that is bad. Just remember that. We never want to leave a negative for exponents. So, in this first example, if we've got we've got a base a to the negative m power. Well, to take care of that, we simply drop it down to the denominator. Okay? So we would write 1 over a to the m power. Okay, so when you see a negative, drop it to the denominator. So in this example, 5 to the negative 3, we simply would rewrite it 1 over 5 to the third power. Okay? Now, just to show you that they are equivalent, again on the calculator, if I do 5 to the negative third power, I get this decimal. And if I take 1 and divide it by, now the trick here is you should get used to using parentheses. I'm going to do 5 to the third power in parentheses because I only want the denominator. You'll notice I get 0.008. Okay. Also, if I convert that, remember your math fraction button, if I convert that, that is actually 1 over 125. Okay, so it becomes 1 over 125. Think about it. 5 to the third power, 5 to the third power is 125. So when I stick a negative on it, and I use my fraction button, whoops, it didn't like that. Let's see what I did wrong. Oh. Okay, negative third, and then math fraction. There we go. And again, 5 to the positive third was 125. So a little trick there if you think through it. All right, so the one now, this example here, you will notice that the exponent is in the denominator and it's negative. Okay, here's a little saying. Cross the line, change the sign. Let me write that. Cross the line, change the sign. So this one, I'm going to bring it up, so it's going to be x to the fifth power. Cross the line, change the sign. Okay, next. This one you should remember. Anything to the 0 power, it's called the 0 exponent. Anything to the 0 power is always 1. Okay, so it doesn't matter what it is. 9,876 to the 0 power is 1. All right, quotient of powers. So in this case, we have a fraction. Now notice again in this problem, we have the same base, and our exponents are m and n. Well, when we are dividing, or you have a fraction, you are going to subtract the exponents. Okay, so like 10 to the 8th over 10 to the 3rd is 10 to the 8 minus 3, which is 10 to the 5th. Okay, so again, that's the quotient of powers. The next one, power of a quotient. So in this case, you will notice we have something inside parentheses. It's a over b, so a divided by b. All of that is to the m power. You notice the parentheses go around the top and the bottom. Well, when that's the case, the m gets shared with both the a and the b. Okay, so in this example over here, we can rewrite this as 6 to the 3rd power over 11 to the 3rd power. Now, you could go ahead and simplify that a little further. So you can just take 6 to the 3rd power and find that out. That's 216. And 11 to the 3rd power is 1,331. Okay, so you can rewrite that and simplify it as much as possible. Okay, now we're going to do some simplifying. So, There's usually more than one way that you can get to the correct answer when you are asked to simplify using exponents. Now, you will notice in this problem, this 3 is all by itself. It is not included in the parentheses. So, that 3 is going to stay where it is. Okay, I'm going to color code this as we go. Now, the numerator, all of that is to the 4th power. So I'm going to rewrite that as x to the 4th power, because remember, there's a times sign here, so the 4 goes to the x, and y to the 8th power. So 4 times 2 is 8. Now I'm going to do the denominator. So you'll notice all of this is inside the parentheses, and it's all multiplication. So this 3 is going to go to all of them. We're not doing a FOIL here. Again, if it was a plus or a minus somewhere in there, you'd have to do a FOIL. But that's not the case. All right, so we have 3 to the 3rd power. And then, because the 3 goes to that, becomes an exponent there. And then here, it becomes x to the 6th power, because 2 times 3 is 6. And then y to the 3rd power. Okay, now I'm not done yet. I'm going to rewrite this, so the numerator is 3x to the 4th, y to the 8th, all over. Now, 3 to the 3rd power becomes 27, and then I have x to the 6th and y to the 3rd. All right, now, I've got to simplify. So I'm going to take 3 over 27, and I'm going to reduce it. That becomes 1 over 9. Now, the x to the 4th and the x to the 6th is going to simplify. Using my rule, x to the 4th over x to the 6th, okay? Now, if I take x and go 4 minus 6, because that's what the rule tells us, I get x to the negative 2. But remember, I don't want a negative exponent, so I'm going to rewrite that as 1 over x squared. So the x squared needs to be in the denominator. I do not need to write the 1 up above it, because I already have a numerator up there. And then y to the 8th over y to the 3rd. Again, I'm going to subtract, because that's what my rule says. So that's going to stay in the numerator, however. So y to the 8 minus 3, which is y to the 5th. So y to the 5th. Now, I really don't like the way that looks, so I'm going to just rewrite that as y to the 5th. I do not need the 1 over 9x squared. Okay. Again, at any time you need to pause this or rewind it, go ahead. All right, next example. Whoa, okay, there's a lot here. So we're going to do one thing at a time. We're going to start with this first one. Okay, all of this, again, there's a times sign in between all of that, to the 2nd power. So that's going to become 2 squared times a to the negative 8. I'm multiplying. Negative 4 times 2 is negative 8 times b to the 4th. All right, now I'm going to go over here, and I'm going to go 3 to the 3rd. So there's a times here, so times 3 to the 3rd, a to the 9th, b to the negative 3. Again, 3 times 3 is 9 for a to the 9th, and negative 1 times 3 is negative 3. All right, now, I've got a lot going on here. So I'm going to use my product properties here. Okay, so first of all, 2 squared becomes 4. And 3 to the 3rd becomes 27. All right? Now, I'm going to multiply those two together. So what I'm going to do, I'm going to erase this here quick. And I'm going to just go off to the side and do this scratch work. So again, 2 to the second power is 4, 3 to the third power is 27. And I'm going to multiply those together. And that becomes, I believe, 108. All right, so these two become 108. Now, a to the negative 8 and a to the 9th. Okay, a to the negative 8 times a, whoops, let me rewrite that. That's horrible. A to the 9th. Okay, the rule here says I can add these two together. Okay, well, negative 8 plus 9 is 1. So that's a to the first power. Okay, now I'm going to do the b's. So if I put the b's, same thing with the b's, right? So b to the fourth power times b to the negative 3 power, I add those together, that's b to the first power. Now, I don't quite like that answer like that because we don't need the 1 for the exponent. So we're just going to write 108 times a times b. Remember, if there is no exponent there, it is implied that it is a 1. But if you need to, you can get rid of it. All right? Hopefully, these examples are good enough for you to be able to do the problems that you're required to do. Go back and watch the different properties. And don't try to do all of the properties at once. Okay? Break it down and do one property at a time. All right, one more thing we need to talk about. Scientific notation. Now remember, when we do scientific notation, we want the first number to be somewhere between 1 but less than 10. So like this problem here, we're going to want to put the decimal between the 7 and the 6. So we would write 7.6 times 10. Now, how many decimals or how many digits are there? 1, 2, 3, 4. These 4 would be behind it, but we don't want to write the zeros in. So we write 7.6 times 10 to the fourth power. Okay, now there is the calculator notation that we'll talk about here in a little bit, but let's continue with this first. Okay, this next one. Again, I want the decimal right here. So I'm going to write 4 point. Now I do have to put 001, but the zeros in the back are not necessary. Times 10. Now how many digits? 1, 2, 3, 4, 5, 6. So 4.001 times 10 to the 6th power. Okay, the next one. Again, I want the decimal right here. So I'm going to put 1. But since the zeros are going to drop off, I don't need a decimal. I only need a decimal if there's another number behind it. So I don't need to physically put the decimal there. So 1 times 10 to the 2nd power. Okay, next one. I want the decimal right here. So 4.2 times 10. Okay, but now this is a really small number. We're going backwards. So how many did we go? We did 1, 2, 3, 4 backwards. So that would be negative 4 for its exponent. Okay, and then this last one, we want the decimal actually behind the 7. Now again, there's not going to be any more numbers behind the 7, so we don't need to put a decimal there. So 7 times 10. Now, how many digits? 1, 2, 3. So that, and again, it's backwards. It's a small number, so that would be 7 times 10 to the negative 3rd power. Now, calculator notation. The calculator will do scientific notation for you. Let me show you on the calculator. If you go to mode, okay, now I highly recommend not doing this, okay, but I'm going to show it to you. If you do change this on the calculator, I need you to change it back to normal mode. Okay, but there is a scientific notation mode right in the middle. So again, I hit the mode button and then I go over once. But please, 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 if you do this, Put your calculator back to normal before turning it in. Okay, so if I do scientific notation mode, okay, quit, clear. All right, now when I type something in, like this first problem, 76,000. So I'm going to type that in as normal. 76,000. I'm going to hit enter, and it is now giving it to me in scientific notation. 7.6E4. Now, I never want to see you write, excuse me, I never want to see you write this on a test or a worksheet. I want you to write it appropriately. Okay, so this E4 represents the times 10 to the 4th. Okay, again, I don't want to see it written this way. So realize that E4 means times 10 to the 4th. Let me demonstrate with the 0.0042. Okay, so if I type in 0.00042, okay, did I get too many zeros on that? 3 zeros? Nope, I didn't. Okay, so you'll notice it gives 4.2 E negative 4. Okay, so 4.2 E negative 4. Again, that E negative 4 represents times 10 to the negative 4 power. But I don't want you writing it that way. I want you writing it the way it's supposed to be written, times 10 to the negative 4. Now, again, let me point out, if you change it, please make sure you go back to your mode and change it back to normal. Okay, moving on. Now, this next problem, you're going to have some like this on your worksheet. Okay, so you can simply multiply these two together. Okay, so if I multiply these two together, this is what I get. Okay, I'm just going to multiply them like normal using the calculator in normal mode. So I'm going to get 1092 followed by 6 zeros. Okay, I just multiplied them like normal. Use a calculator. I want my decimal to be right here. So 1.092. The rest of the zeros get dropped off, times 10 to the 1, 2, 3, 6, 7, 8, 9. Okay, same thing with the next one. You can just take your calculator, you can multiply those together, and you're going to get 112,000. And I want the decimal be right here. So 1.12, those zeros are not necessary, times 10 to the 1, 2, 3, 4, 5 to the 5th power. Okay, 2 more examples. Oh, 3 more examples. Okay, so you have a problem like this on your worksheet and in your book assignments. So you can actually type this in like you see it. And then, so let me just demonstrate. So 4.05 times 10 to the 5th. So I'm going to do this. 4.05 times 10 to the 5th power. All of that is in parentheses. Times 3.1 times 10 to the negative 2. 3.1 times 10 raised to the power of negative 2. Oops. Get back. There we go. So just type it in like you see it. You're going to get an answer. Okay, 12,555. Again, if your calculator's in scientific notation mode, it will do it for you. Just remember to write it correctly. We want the decimal right there. Times 10 to the 1, 2, 3, 4 to the 4th power. Okay, same thing with these. use parentheses on the numerator and denominator. Okay, type it into your calculator. So we're going to type in 4.5 times 10 to the 8th. 4.5 times 10 to the 8th power. And we're going to divide by 1.5 times 10 to the 6th. 1.5 times 10 to the 6th. Get an answer. Oh, 300. Okay. So 300, but as scientific notation, that would be 3 times 10 squared. All right, and do the same thing with this one. Okay, I'm not going to type that one in. Take 2.6 times 10 to the negative 4, divided by 6.5 times 10 to the negative 11, and have the calculator spit out your answer and convert it to scientific notation. All right, so I'm going to do a quick recap. All right, so product of a power, we add exponents. Power of a power, one base, two exponents, we multiply the exponents. Okay, power of a product, we've got two bases with a times sign in between. That exponent goes to all the bases. And if there's exponents, like down here, x squared, y to the third, we multiply the exponents together. So 5 times 2, and then the 5 times 3. Negative exponents. Remember, never leave a negative exponent. Okay, cross the line, change the sign. Zero exponent. Everything always equals 1. Quotient of a power. Okay, that's where we have the same base in the numerator and denominator, and we subtract the exponents. Power of a quotient. So we've got a numerator and denominator, two different bases, all grouped to an exponent, to some power, and that power, that exponent, goes to everything inside, top and bottom. Simplifying, okay, we applied the rules to these problems where you have to break it up, simplify it as much as possible. And here's another one. And then we did scientific notation. All right, that is chapter 5.1. Good luck.